Mathematical induction, part 3.
Hello everyone. In this session, we will discuss 7 marks question. This is the continuation of previous class. ఒకవేళ మీ ప్రీవియస్ క్లాస్ కావాలంటే లింక్ డిస్క్రిప్షన్ లో ఇచ్చాను చూడండి. సో వితౌట్ డిలే కమింగ్ టు టాపిక్, show that 1 into 2 into 3 and 2 into 3 into 4 and 3 into 4 into 5 up to n terms. So means here first you need to find the nth term of the given series. See the solution. So here for finding the nth term of the series, we can consider first two terms. What are the first two terms? 1, 2, 3. Clearly 1, 2, 3 and so on. What is the difference of 1 and 2? 1. Difference of 2 and 3? 1. Here the common difference is same. We can say that the given series is in AP or in AP series. And what is the first term? A is equals to 1. And what is the common difference? So D is equals to 1. So here you can find the nth term of the series. We know that nth term Tn is equals to what? A plus n minus 1 into D. A equals to 1 and D equals to 1. Substitute here 1 plus n minus 1 into 1. Clearly plus 1 minus 1 cancel, you will get n. Therefore nth term of the first terms is n. Similarly we can consider second terms. So what are the second terms? 2, next 3, 4. So 2, 3, 4 which are also in AP series. Here also common difference is same. And what is the first term? 2. So A is equals to 2. And D is the same, that is equals to 1. And we can substitute in the nth term formula. A is a 2 and D is 1. That is a 2 plus n minus 1. So therefore nth term Tn is equals to n 2 minus 1 plus 1. So next terms 3, 4, 5. Clearly 3, 4, 5 and so on, which are in AP series. A is equal to first term, that is 3, and common difference is 1. Substitute in the nth term formula. Tn is equals to A plus n minus 1 into D. A is 3 and D is 1. That is 3 plus n minus 1. Therefore Tn is equal to n. 3 minus 1, 2. Okay. Now clearly what is the nth term? Product of the terms all are. So product of these nth terms, that is n into n plus 1 into n plus 2. That is our nth term. So therefore we can write the statement, let S of n, so which is what? 1 into 2 into 3 plus 2 into 3 into 4 and so on. What is the nth term? N into n plus 1 into n plus 2. So which is equals to what? N into n plus 1 into n plus 2 into n plus 3 divided by 4. So clearly this is the given statement, which is LHS and which is RHS. So what is the case 1? You prove for n is equals to 1. So which means you can consider LHS and RHS separately. See here n is equals to 1 means first term. What is the first term? Clearly that is 1 into 2 into 3. So clearly product of these 3. 2 into 3, 6. And consider RHS. So what is RHS? N into n plus 1 into n plus 2 into n plus 3, which is divided by 4. Now we can replace n by what? 1. That is 1 into n is what? 1. 1 plus 1, 2 into 1 plus 2, 3 into 1 plus 3, 4 divided by what? 4. So 4 it cancelled. 2 into 3, again 6. Clearly, LHS 6 and RHS 6. So we can say that the given statement is true for n is equals to 1. Next, case 2. Case 2 is what? Assume that n is equals to k. So which means we can replace n by k in equation 1. So directly we can write LHS is equals to RHS because of already we assumed the given statement is true. So here that is 1 into 2 into 3 plus 2 into 3 into 4 and so on, plus replace n by what? K. K into k plus 1 into k plus 2, which is equals to, on RHS also you can replace n by what? K. That is k into k plus 1 into k plus 2 into k plus 3, which is divided by 4. This is equation 2. And what is the last case? We prove for n is equals to k plus 1. So we can consider LHS. From that we can prove RHS. So first consider LHS of equation 1. So what is LHS? This one. 1 into 2 into 3 plus 2 into 3 into 4 and so on, plus, see here replace n by what? K plus 1. So we should mention the bracket for k plus 1. That is k plus 1. Next, k plus 1 plus 1. Next, k plus 1 plus 2. So clearly which is what? Sum of the k plus 1 terms. So which can be written as sum of k terms plus last term. So which means RHS of case 2 plus last term. So right, RHS of case 2 plus last term. So clearly what is the RHS of case 2? This one only. That is k into k plus 1, k plus 2, k plus 3, which is divided by 4, plus what is the last term? This one, k plus 1, k plus 1 plus 1, that is k plus 2. Next, k plus 1 plus 2, that is k plus 3. Okay. Now clearly from these two terms, k plus 1, k plus 2, k plus 3. Here also k plus 1, k plus 2, k plus 3 is common. So that is k plus 1, k plus 2, k plus 3, which is common. So what are the remaining terms? In the first k by 4, all terms are common, only 1. So which is, what is the LCM? 4. This is as it is k plus 1, k plus 2, k plus 3. And which is cross multiplication? K plus 4 into 1, 4. So clearly which can be written as k plus 1, k plus 2 write as k plus 1 plus 1, k plus 1 plus 1. Next k plus 3 write as k plus 1 plus 2, k plus 1 plus 2. Similarly k plus 4 write as k plus 1 plus 3, which is divided by 4. So once you observe the RHS, what you got? In place of n, observe here, in place of n what? K plus 1. So we can say that the given statement is true for n is equals to k plus 1 and write case 4. So what is case 4? By principle of mathematical induction, the given statement true for positive integers. Okay. So this is the actual process, and go for a second method, that is the reverse method. So do from back side, that is what? Write in place of n what? K plus 1, that is the answer. So write here k plus 1. Next, k plus 1 plus 1. Next, k plus 1 plus 2. Next, k plus 1 plus 3. which is divided by 4. Again write before step. K plus 1, K plus 1 plus 1. That is K plus 2. Next K plus 1 plus 2. K plus 3. K plus 1 plus 3. K plus 4. Which is divided by 4. So clearly these both terms are coincides. Okay, this is the second method. So next fourth one. Show that 2 into 3 plus 3 into 4 plus 4 into 5 up to n terms. So here also first we can find the nth term of the given series. So here clearly we can consider first terms 2, 3, 4. 2, 3, 4 and so on. What is the difference here? Difference between 2 and 3, 1. Difference between 3 and 4 also 1. So clearly the common difference is same, which are in AP series. Clearly what is the first term? A is equals to 2 and difference is what? 1. And we know that nth term formula is A plus n minus 1 into D. A is 2 and D is 1, which is 2 plus n minus 1 into 1. So which is n? 2 minus 1, 1. So clearly what is Tn? N plus 1. So what are the next terms? 3, 4, 5. Clearly 3, 4, 5. Here also difference same. So which are also in AP series. What is the first term here? 3 and the difference is 1. Substitute in the formula. So Tn is equals to 3 plus n minus 1. So what is Tn now? N plus 2. Therefore our nth term is n plus 1 into n plus 2. So we can write the given statement. Let S of n is 2 into 3 plus 3 into 4 plus 4 into 5 and so on. What is the nth term? N plus 1 into n plus 2. So write n plus 1 into n plus 2, which is equals to n into n square plus 6n plus 11 divided by 3. Okay. So this is our statement clearly, which is LHS and which is RHS. So this is equation 1. So next, case 1. So what is case 1? You prove for n is equals to 1. So here n is equals to 1 means you can take first term. That is what is LHS? 2 into 3, which is equal to 6. And consider RHS. What is RHS? This one. N into n square plus 6n plus 11 divided by 3, which is equals to, replace n by what? 1. 1 square. 1. 6 into 1. 6 plus 11 divided by 3. So which is equals to 1 plus 6, 7 plus 11. 18 by 3. So 3 ones are 3, 6. Clearly LHS, RHS are equal. We can say that the given statement is true for n is equals to 1. And what is the case 2? Assume that n is equals to k. So just you can replace n by k in equation 1 in both LHS and RHS. That is 2 into 3 plus 3 into 4 plus and so on plus what is n? N is k. That is k plus 1 into k plus 2, which is equals to, on RHS also replace n by k. That is k into k square plus 6k plus 11 divided by 3. So this is equation 2. So next, what is case 3? You prove for n equals to k plus 1. You can consider LHS and replace n by k plus 1. From that you can prove RHS. So here what is LHS of equation 1? This one. That is 2 into 3 plus 3 into 4 plus and so on. Plus, how to write n plus 1? N is what? K plus 1. So that is, you should mention the bracket for k plus 1 plus 1. Again n plus 2. Replace n by what? K plus 1. that is k plus 1 plus 2. So what is the next step? Clearly, which is what? Sum of k plus 1 terms. You can write as sum of k terms plus last term. So that implies what? RHS of case 2 plus last term. So clearly, what is the RHS of case 2? This one. That is k into k square plus 6k plus 11 divided by 3 plus last term. What is the last term? This one. That is k plus 2, k plus 1 plus 2. That is k plus 3. So which is divided by 1. So clearly, what is the LCM? 3 is the LCM. Now cross multiplication. K into k square, k cube, k into 6k, 6k square, k into 11, 11k plus 3 into this one, 3 into multiplying these two, k into k, k square plus k into 3, 3k plus 2 into k, 2k plus 2 into 3, 6. Okay. Now we can simplify this, which is k cube plus 6k square plus 11k plus multiplying with 3, 3k square plus 3 into 3k, 9k plus 3 into 2, 6k plus 3 into 6, 18, which is divided by 3. Again, which is k cube, and see the like terms, 6k square plus 3k square, 9k square plus, right, k terms, 11k plus 9k, 20k plus 6k, 26k plus constant. What is the constant? 18, which is divided by what? 3. So this is the LHS part. So in that case, you can consider RHS. So what is RHS? This one only. So here RHS is n into n square plus 6n plus 11 divided by 3. So we can replace n by what? K plus 1. That is k plus 1 into k plus 1 whole square into 6 times of k plus 1 plus 11 divided by 3. So here which is k plus 1 into. We can simplify this. A plus b whole square, that is k square plus 1 plus 2k, and multiplying with 6. 6 into k, 6 plus 6 into 1, 6 plus 11, which is divided by 3. Again, k plus 1 into k square, 2k plus 6k, 8k plus 1 plus 6, 7 plus 11, 18 divided by 3. Multiplying with k into k square, k cube plus k into 8k, 8k square plus k into 18, 18k plus multiplying with 1, you will get same. That is k square plus 8k plus 18 divided by what? 3. Again, which is k cube, 8k square plus k square, 9k square, 18k plus 8k, 26k plus 18 divided by what? 3. So clear, this is LHS and this is RHS. So both LHS and RHS are equal. You can say that the given statement is true for n equals to k plus 1, and write case 4. So what is case 4? By principle of mathematical induction, the given statement is true for n belongs to n. ఈ వీడియో మీకు నచ్చినట్లయితే లైక్ అండ్ షేర్ చేయండి. అలాగే ఈ వీడియోలో ఏమైనా డౌట్స్ ఉంటే ప్లీజ్ కామెంట్ చేయండి. థ్యాంక్ యూ.